So one thing I haven't seen a lot of discussion of is the use of true and false in programming. So if you remember back to my variable video, and when we talked about types, we said that one of the types was Boolean. So I can say things like this. I can say A equals false, and I can inspect the value of A, and I can say what's the type of A, and it'll tell me that it's Boolean. And I can do the similar thing with true. Notice that I need to use capital letters for the first letter of true and false, whereas I don't in JavaScript, but other than that, lots of what I'm doing will hold true for other programming languages. Okay, so we can have a variable and we can give it a Boolean value, but how are we going to use that in programming? So we can just literally do that. So if I wanted to find out, for example, whether a number was prime or not, I could use this idea. So one of the things I could do is, this is quite a simplified version. If you have a look at my list of repls, you'll see a more sophisticated version. So we can say, we'll create a function, is this a prime number? And what we're going to do is we'll assume that it is. So I'm going to say prime is true unless I find evidence to the contrary. So how are we going to find evidence to the contrary? Well, what I'm going to do is I'm going to look through all of the numbers up to the square root of the number that we're testing. Don't need to try 1 because we know 1 is a factor of a number. So I'm going to start at 2 and I'm going to go up to the square root, because any factor less than the square root will have a corresponding pair bigger than the square root. The square root, there's no square root function in Python unless you import one, but you can raise things to a fraction power. So raising something to the power of 0.5 is the same as finding the square root of it. And then I'm going to make that a whole number, otherwise it might cry when I try to count from 2 to a fraction. And then, because Python always stops 1 short, I'm just going to add 1 to that. So I'm going to count up to the square root, and what I'm going to do is I'm going to test whether n is a factor of number, and I'm going to do that using modular arithmetic. So I'm going to say if so number, so mod, mod in languages such as BASIC, the percent symbol in JavaScript and Python, if number mod n is 0. So what that means is if we divide number by n and get no remainder, then n is a factor, in which case prime is false. And if we were doing more sophisticated version, we'd stop there, but this one's just going to carry on. And then what we want to do at the end is we just want to return whether it's true or false. So that's a kind of fairly straightforward example of how we can use the Boolean data type. And hopefully if I run this now and I say is prime 7, it's going to say true. And if I say is prime 8, it's going to say false. So there I've set a variable to be true and then possibly set it to be false and then return that value. That's not really what this video is about. What this video is about is how to take advantage of true and false in other settings. So imagine this another simple program. What we're going to do is we're going to ask the user for a number. So we're going to say give me a number. Give me a number. And what we're just going to say whether it's negative. So okay, it's a very simple program. So how are we going to do that? We could do it something like this. So we could say if number is less than 0, then print that's negative. Okay, so that's a very simple program. We could have an else and say otherwise, say that's not negative. Let's have a look at that. So give me a number. If I say 10, it'll do nothing. And if I give it a negative number, -4, it'll say that's negative. Okay, fairly straightforward. So one of the things that sometimes people miss when they first start to program is that lots of things, such as expressions in if and while, are evaluated to say whether they're true or false. So how this works is Python will interpret that number less than 0, and that will say whether that is true or false. So over here, hopefully that's retained my value of number. There we go. So if I now do that comparison, number less than 0, I'll get a true or a false. So I can do other comparisons as well. So if I say number equals -4, obviously that'll be true. If I say number equals 1, that'll be false. So you can do a comparison and it'll evaluate that and say whether it's true or false. So all ifs and all whiles are really just if true or if false. So we can also take advantage of that by, we can set a variable to be equal to a comparison, which seems a little bit strange to start with, but we can do this sort of thing. So if you imagine we wanted to have a variable, a Boolean variable, to tell us whether the number was negative or not. So we can say equals, and then we can say number less than 0, and what it'll do is it'll do that comparison, evaluate that to be true or false, and then set that value, define the value of negative to be that value. Okay, so what we can then do, well, what beginners sometimes do is say this. So if negative equals true, then we'll print that's negative. Okay, so this is probably a less good program than the previous version because we are unnecessarily storing negative, but it's just a demonstration of the point. So now, obviously, I need to remember to do 2 equal signs. There we go. So give me a number. So 10. So that hasn't said anything because it's not negative. If we have a look at the value of negative, it will say false because number less than 0, is that true? No, it's not. It's false. So negative becomes false. And we've checked whether it's true, and it's not, so we don't print that. However, this bit is redundant because that's really saying, so negative is either true or false. So what we're saying is true equal to true, and obviously that is, or is false equal to true. And obviously it's not. So a beginner's kind of mistake is to put that in when you don't really need to. So if you're just saying equals true, then, well, the whole thing equals true. So that's a bit like saying if numbers less than 0 is equal to true. So obviously that second one is redundant. So now this will do the same thing. So now we can say, let's do it the other way around. So -2. And it's going to say that is negative because, let's have a look at the value of negative. That is now true. So we can take advantage of that expression evaluating to true and false and actually set a variable to be equal to that. But we can go one step further than that. We can actually use Boolean values as things like list or tuple indexes or in calculations because in most programming languages, and certainly this is true of Python and JavaScript, true and false are really just synonyms for 1 and 0. So if you cast true, for example, to be an integer, what you'll get is 1. And if you do int false, you'll get 0. But actually, you don't need to do that because if you do something like this, if you do 3 times true, you get 3. And if you get 3 times false, you get 0 because even without converting it to an integer, Python treats it as a 0 or a 1. So we can do things like this. So imagine we had a simple a game. So what we wanted to do is we're going to get the computer to toss a coin. And what I'm going to do here is you could do something like this. So you could say from random import randint. So what I'm going to do is I'm going to use a number, 0 or 1, to represent my coin. So I know that you can get Python to choose a value from a list, but you're unlikely to be able to do that in other languages. And also, if I want to introduce bias, I'm not going to be able to do that so easily with values from a list. Or if I want to change the distribution, and I have written an article on that, which I'll post a link to in the comments section. So if I wanted to do that, I could do the computer equals, and I could say randint 0 and 1. And I could, for example, assume that maybe 0 was head and 1 was tail. So let's have a tuple. So what I'm going to do is I'm going to have a tuple, and I'm going to say head and tail. So the computer's going to pick one. But if I wanted to bias this, I could use the random function. Now the random function, if you just run this, it doesn't like that because yes, let's not worry about that. So the random function works like the random function does in most other programming languages. So if I just do random, it's going to give me a number between 0 and 1. So if I want to bias my throw, for example, what I could do is I could say random greater than, say, 0.33. So what that would mean is 2/3 of the throws of the coin would give you the 1, and 1/3 would give you the 0. So that means the coin would be biased towards, in this case, tails. So that's going to give me true or false, because I'm evaluating this to say, is the number generated by random greater than 0.3? So that'll be either true or false. But look what happens if I do that. So if I do then print side computer, so computer is what the computer is checking, what's it going to print? So it's printed tail. So how's that worked? Well, it's because if random is greater than 0.33, that'll be true, and true behaves as 1, which will give me a tail. If it's less than or equal to 0.33, it'll be 0, it'll be false rather, which will behave like 0, and it will give me a head. So you can take advantage of true or false and actually use it as a tuple or a list index. So that's quite useful. And obviously I've got some bias here, so I'm just going to change that to make it a bit more, bit fairer. Okay, so now it should be kind of pretty much half and half. So what we're going to do in our game is we're going to ask the user what they want. So we're going to say user equals, and obviously in a real game I would add some validation to make sure it's okay, but I'm going to trust myself to type in the numbers correctly. So I'm going to say input, so let's say, was it 0, 0 for head and 1 for tail. So I'd make this a bit more user friendly if I was doing this myself. And so then what we're going to do, so we're going to compare that with what the computer guessed. So we can compare that quite easily numerically because, well, let's have a look. If we say false equals 0, it says true. So even comparisons like that take false to be 0. So it's not a problem that the computer guess is true or false and the user guess is 0 or 1. So what about then, so we're going to score it. Okay, so we need to have a score to begin with. And maybe we're going to give them 3 goes. So we'll say for n in range 3. So best of 3. So we're going to ask them 3 times. And then we're going to give them a score. So how are we going to increment the score? Well, we'll give them a point if their guess is the same as the computer's guess. Okay, so we could print that. So we could say print you guessed, and then what we're going to have is side user, and the computer tossed side computer. So we're going to use the user, which is an integer, and the computer, which is a Boolean, both to look up a random side. So let's just run that, just check that's working. So I'm going to go, it's going to do this 3 times, remember. So I'm going to go head, 0 for head, So it's going to say you guessed head and the computer tossed head. Okay, let's go for tail this time, just make sure it works. So I guessed tail and the computer tossed head. Okay, and then so it's done it 3 times and then it's stopped. Okay, so if I was correct, we want to score a point. So I'm going to add 1 to my score. So you could do something like this. You could say if user is equal to computer. So if I guessed the same as the computer chose, then score plus equals 1. Otherwise, we're not going to do anything, so we don't need an else. In this case, that's 2 lines of code. That's okay. That's not too complex. But we could, again, take advantage of this idea of true and false being 0 and 1 by just doing this. We could say score plus equals, and then we're going to check. If we do this comparison, if we say user equals computer, so this bit here will evaluate to either true if I guessed the same as the computer guessed, or false if they're different. And because if they're the same, true is the same as 1, it'll add 1 to the score. And if they're different, false is 0, and it'll add 0 to the score, so it won't update my score. So now what we can do is when we get to the end, so user equals computer, there we go, and then all we need to, we'll just print score to begin with. So now if we do that 3 times, so I'll just go 3 heads. So I've got one right there, I've got 1 wrong, and so I've got 2. Yeah, so that's looking okay, isn't it? So what about if I wanted to say now how well I'd done? So what I could do is I could say if you scored 0, then say oh dear, you scored 0. Otherwise, I could say well done, you scored whatever you scored. However, that would be 4 lines of code, wouldn't it? So what we could do is we could use again this comparison, true or false, to look up from a tuple. So if the score is, well, it doesn't really matter which way around there. So you could have either oh dear, and being a bit of a perfectionist, I'd want my capital letters there, oh dear, or well done. So that's my kind of prefix. So what I'm going to do is I'm going to say, I'm going to pick one of those prefixes based on what my score is. So if my score is 0, I'm going to pick oh dear. So I'm going to pick, so we want prefix, so score not equal to 0. So if the score is 0, that'll be false. So we get oh dear. What might be clearer to do actually is to just swap those around. So let's do that. So I didn't do very well there, am I? So comma, there we go. So if it is 0, so that will then be true, then that'll be 1, so we'll have that one. Okay, so prefix, so oh dear, you had, and then we'll have the actual score, and then we'll say correct guesses. Okay, so let's run this then and see what that does. So obviously, because it's random, I can't guarantee that I'm going to score 0. So in fact, I've already scored more than 0. Okay, so I scored 3, and it's telling me well done. So let's just have another go. I'm not going to make you sit through. Okay, excellent. So now I got 0, and it said, oh dear. Right, so that looks like that's working. What about, though, this guesses? So if I score 1, let's have a look at this. So if I go 1, So 2 correct guesses. Okay, that's right. Let's see if I can get 1. No. Well, I'm sure you can appreciate the idea. So this, if it says, the answer is going to be 0, 1, 2 or 3, isn't it? So what would that sentence say under each of those different circumstances? So no correct guesses, 1 correct guesses, 2 correct guesses, 3 correct guesses. So it's not going to sound right if I score 1. So what can we do about that? We could say, well, we could have a variable, a string variable that contained the word guess, and we could say if score equals 1, then that variable is guess, otherwise it's guesses. But we could take advantage of the fact that in Python you can multiply. So you might remember back to the string manipulation video, and we said things like you could do this. So you could do, if you had a and you multiplied it by a value, so if you said a times 6, for example, it will give you 6 a's. So it's quite unusual to be able to multiply text, but you can do it. And what also happens there, if you say a times 0, so it does behave kind of numerically. If you multiply text by 0, you get nothing. So can we take advantage of that? Well, yes, we can. So what we can do is we can say, we'll have guess. Now, we can't use comma for this because when you put a comma, you put a space in. So I'm going to have to use plus. So I'm going to have plus, I'm going to still put the exclamation mark on the end. So how many s's do I want? I only want that if the score is not 1. Okay, so if the score is 1, I don't want the es, otherwise I do. So if we have score equals, not equal to, score not equal to 1, okay, so if the score is 1, that'll be false, which will be 0, and if the score is anything other than 1, that'll be true, which will be 1, so it will give me 1 lot of es. So we can use it even for things like this. So if I run this now, let's have a look. So 1, 0, 0. And in fact, straight away, we've got 1 correct guess. And if I run that again, so 0, 0, 0, got 3 correct guesses. So that's without having to use any ifs. So I've got multiple outputs, so it can either say oh dear or it can say well done. I can say head or tail. I can adjust the score, and I can have guesses or guess, all without using if, all taking advantage of being able to use true and false in Python. So as I said earlier, this will also work in JavaScript. So JavaScript is pretty much the same, except true and false don't begin with a capital letter. If you're using something like Visual Basic, you need to be a little bit careful, because in Visual Basic, false is 0, but true is -1. But you can always multiply by -1, or you can use the absolute value. The other thing you can do is you can multiply by things. So if you had, for example, a cost of an item, so we'll just do it in simple form. So if the cost of an item was £10 and the postage was, say, £2, then you could ask whether they wanted it posting. So so you could say post equals false. So if they don't want it posting, and then so if they want and then let's say number equals 3, so they want 3 of them. What you could do is you could evaluate, so if you said number times cost plus postage times post, what that will give me, it'll give me £32, won't it? Because sorry, no, it won't. It'll give me £30 because I'm buying 3 things at £10 each, but I'm not posting them. So if I just copy and paste that, if I now say postage, postage, I don't know what that's doing. postage. Right, okay. Let's just refresh that. So let's just do the postage again. So if I do postage is, say, £2 and post is false, then if I do postage times post, so it's going to cost me nothing to post it if I'm not posting it. If I now say post is true, then postage times post will give me 2. So you can multiplying by a Boolean value is quite useful. That's really just the numerical equivalent of what I did here with the ES on the end of guesses. So that's a quick tour of some more kind of sophisticated, I guess, uses of true and false in a Python program, rather than just using a Boolean variable to store that value.